I don't know. I think it goes the other one. Yeah. Certain graphs, specifically those that are differentiable, have a property called locally linear. Meaning, if you zoom in both directions on a point, the graph eventually appears to look like a straight line, whose slope is the same as the slope of the derivative of the tangent line. So I'll give you a little quick thing of what I'm saying there. I have this magic pen here. I got to move this. Hold on. The magic pen. If I draw a square on there, stop it. It's supposed to actually. That's not magic then. Oh, now it's disappearing. There, it didn't. Okay, so that's what's supposed to happen. It's supposed to zoom in here. So do you see the blue curve almost looks like it's the same as the red line that was there behind it. Do you see? When you zoom in so close, it looks like it's basically a straight line. So that's what I'm trying to say there. All right, so the definition of linearization is if f is differentiable at x equals a, then the equation of the tangent line L of x equals f of a plus f prime of a times x minus a. So you think, oh my gosh, this seems so ridiculous or whatever. But all this is this is the normal equation, this is the derivative, and then this is, of course, the point a, whatever it is. It's not as hard as it thinks. So this is just an approximation. So they asked this several times, and honestly, in the university calculus, we don't even actually really even talk about this. But for some reason, AP really likes it, so thus we're doing a lesson on it. So the approximation of f of x is approximately L of x is the standard linear approximation of f at a. The point x equals a is the center. So that means I'm just focusing in on that center of that. So if we take a look at that, does everybody see if I focus in at the point A, right in that little spot, the blue curve looks pretty much the same slope as the red line. So from this graph, we can see that near x equals a, the tangent line and the function have nearly the same graph. On occasion, we use the tangent line L of x as an approximation to a function near x equals a. In these cases, we call the tangent line the linear approximation to the function x equals a. When approximating the value of the function at a point x equals b, which is close to x equals a, the tangent line's approximation for f of b is. So does anybody remember what kind of curve this is called? Concave down, and this is concave up. So do you see if I have a tangent line to a concave down, so is it greater than or less than the actual tangent line? So I'll word it again. The tangent line, is it greater than the actual is the curve, or less than? Greater. It would be greater than. And it's less than, oh sorry, this should be concave down, sorry. It's already greater than there. Concave down. And when it's concave up, that would be, no, the tangent line would be less than, right, at concave up. Again, I'll repeat. The tangent line is either greater than the as approximation or less than, depending if it's concave up or down. So we're comparing the tangent line. Do you see that would be greater than a concave down? And this tangent line would be less than when it's concave up. Does that make sense to you? Okay. Okay, so we're going to find a linear approximation of e to the power x at 0 and use it to approximate e to the power 0.01, and this is a calculator question. So I'll give you a second to get your calculator out. Just to look back, remember this is L of x equals f of a plus f prime of a x minus a. So the first thing we need to do is find the derivative of e to the power x. Does anybody know what, if y equals e to the power x, what's the derivative equal to? Yes, e to the power x. Does everybody see it's e to the power x? Yeah, it's itself. Okay, so then it's saying find the linear approximation of e to the power x at 0. So we need to find the value of the derivative at 0. Do you see that's this right here? That's that part. So y prime at 0 would equal, yes, 1. It would be e to the power 0, which is 1. Yes? Okay, so then what would the tangent line then be at 0? Like, what would the equation of the tangent line be? Well, first off, let's find the coordinate here. So at 0, it's still 1, right? Okay, which is different than this one. This one's the derivative, right? Okay, so how do we put a tangent line together? Y equals, or y minus 1 equals the slope, which is 1, x minus 0. Yes? So y equals x plus 1. Okay? So there's my tangent line. So now I'm going to use this to approximate e to the power 0.01. So I'm going to plug in 0.01 in. So y equals 0.01 plus 1, and I get 1.01. I guess we didn't need a calculator for that one. But just for fun, on our calculator, let's find what e to the power 0.01 is. Because I know that's fun, right? So e to the power is that number there. Oop, sorry, I'll try again. E to the power 0.01. Does everybody see? Look at my approximation. Pretty darn close, isn't it? Yeah? Okay. 1.01, that's pretty much that right there, right? It's approximation. Okay, approximate f of 3.06 and f of 2.9 given that f of 3 equals 1 and f prime of 3 equals 0.5. So it gives you the slope when x is 3, and this gives you the coordinate. So we should be able to come up with a tangent line, right? So what's the tangent line? Y minus 1 equals 0.5 x minus 3. Is everybody good with what we're doing here? Okay. So y equals 0.5x. 0.5 times 3 is negative 1.5. Plus 1 is negative 0.5. Yes? Okay, so then if I want to approximate f of 3.06, so then f of 3.06 would be 0.5 times 3.06 minus 0.5, and I get, I'll punch it into my calculator, or you can, and you can tell me. Yeah. Well, you could, but it's pretty easy to do, actually. Half of 3.06 is 1.48. 1.58. 1.58. Okay, no. Okay, so anyways, what's my answer? 1.03? Did you get that? Okay, and then f of 2.9 is 0.5 times 2.9 minus 0.5. So what do we get there? What did you get? 0.95? So it's a pretty easy concept. You just have to know what to do, right? Like if you were given this on a test and you've never seen this lesson before, you're going like, oh, I don't know that. Yeah. Right? But now it's pretty easy, right? Okay, so let's move on. Here is an actual question from a AP exam. Let f be a differentiable function that f of 3 is 2, f prime of 3 is 5. If the tangent line to the graph of x equals 3 is used to find an approximation to a 0 of f, that approximation is blank. So I'll give you a second to figure it out. Okay, so here's my point, here's my slope. So y minus 2 equals 5x minus 3. Y equals 5x, that would be minus 15 plus 2, so that would be minus 13, yes? So then if I need to find the 0, that is setting y equal to 0 and solving, right? So then I get 13 equals 5x, so x equals 13 divided by 5, and that's what, 2 3/5? So that's C.
That's exactly 2.
Oh, that would have done better. I just plugged in.
No, this, yeah, and that's what the girls asked. Is this multiple choice or do I have to plug all of them in?
I just plugged them in.
Oh, no. You actually just solve for, yeah.
That would have been faster.
It would have been faster. Especially when you're only allowed probably about a minute and a half per question, right? On the multiple choice. If you want to finish.
I want to know. I want a 45.
You guys want to try the next one? Try the next one. Try the next one. So, did everybody find the derivative? Well, I think I'm going to write it out a different way. Y equals 4 plus sine x to the power of half. So y prime would be 1/2 4 plus sine x to the power negative a half times cos x. Did everybody get that part? So remember, what did I had the derivative, right? But I have to have the, sorry, this is just the derivative. I have to have the derivative at the point.
We're supposed to look at point 1, 2, or 0.
0. 0. Because we're trying to find the y value, like we're trying to find the actual.
Like the answer would be from the point 1, 2.
Yes.
Okay.
Yes. Yeah. We're trying to find the y value at 0.12, but after we've already calculated the actual tangent line at 0. So we need to find y prime of 0. So that is 1, because that would be pretty hard to do without a calculator, right?
That's what I was like,
4 plus sine of 0 to the power negative a half times cos of 0. Okay, so sine of 0 is 0, and 4 plus 0 is 4. So, but this is to the power negative a half, so it's the square root.
so it's just 1 over 2.
Hold on. It's the square root of 2, but it's a negative, so it's at the bottom. So it's 1 over 2 times 1 over 2. So that is 1 over 4, and cos of 0 is 1. So then it's just 1 over 4. So that's my slope at 0, yes? So again, I need, this only gave me my x coordinate, so I need to have my y coordinate. So y of 0 is the square root of 4 plus sine of 0. Sine of 0 is 0. 0 plus 4 is 4. Square root of 4 is 2. So there's my y coordinate at 0. So now we're going to put it all together. Y minus 2 equals 1/4 x minus 0. So y equals 1/4 x plus 2. Now we're going to plug in the 0.12. So y equals 1/4 times 0.12 plus 2. 4 goes into 12.03 plus 2. So that would be B. You got that? Good.
The question isn't worded, but
Let f of F be a function that's differentiable everywhere. The value of f prime is the values of x in the table. If f of negative 5 equals 2, write the equation of the tangent line at x equals negative 5 to approximate negative 4.9. So I'll give you a second. So this would be the case, Crystal, where they're giving you lots of information here that you don't need, right?
Yeah, these tables are only.
The table, yeah, I would say, yeah, in a table question like that, they definitely give you way more information than you need, right? So,
Yeah.
okay, so I'll give you a second to do this. Okay, so it says the derivative at x equals negative 5, so that is this right here. So y minus 2 equals negative 1, x minus 5. So y equals negative x. This would be minus 5 plus 2 would be minus 3, yes? And so then f of negative 4.9 would be 4.9 minus 3, which gives me 1.9.
Oh, I guess it's, yeah.
I think on the Khan Academy for this section, they say you can use your calculator, so.
That one you didn't need to.
You didn't need to, it was easy enough addition and stuff. If f prime of x is always increasing, is the approximation for part A greater than or less than f of negative 4.9?
Less than.
So if it's increasing, think about this. It's concave up, right? Yeah. So concave up is,
It's less than.
it's going to be less than, do you see that? So less than since concave up.
Wait, can you explain why it's less?
Well, look at my tangent line and look at an increasing function. Do you see the tangent line is less than what the curve would be for an
Oh,
approximation? Yeah.